All right, on to literal constants. Now that we understand variables, we need to understand literals, which are simply the values that we assign to these variables. A literal is a constant value that we specify directly. So like you're saying, it's literally 5 or literally 2. In the case above, the literal value of 5 is assigned to the variable a, okay, in the main function. And above that, we are defining a constant up here such that the symbol b represents the literal value 2. So literals don't have to be numeric. The character H is a literal. The string microchip is a literal. And anytime you specify the actual value of something directly in this way, it's called a literal. All right, we're looking at base 10 or decimal integers that are constants that may be as large or small as their variable type. The rules for specifying an integer constant in decimal are fairly simple. You can only use digits 0 to 9. No other characters except for the minus sign at the beginning are valid. Decimal integers other than 0 itself cannot be preceded by a 0 because that is the syntax for an octal or base 8 numbering system. So we can't use, for example, this one here. That's a bad number. Decimal integers cannot contain a decimal point like this one here, even if the fractional part is 0. Okay, and you can see for these other problems here, this has a comma, or sorry, a comma, and then this one has a space, so that's invalid. These ones are all okay. You can't put the negative in front, and they have no spaces, no decimals, and 0 is fine. You just can't have 0 precede another number. Okay, on to hexadecimal integers, which have most of the same restrictions as decimal integers. Hex numbers must begin with a 0x prefix. So this has no value on its own. It's just a prefix that indicates that the following digits ahead of it are in base 16. The digits themselves contain the digits 0 to 9 and the letters A to F, which may be upper or lowercase. So I encourage you to use primarily use hex. It's a very useful numbering system to use in your programs because the 4-digit hex number represents the full 16 bits of this microcontroller. All right, in the base 2 numbering system of binary, it's virtually the same thing as we just looked at with hex, except instead of 0h, it's 0b that's used as a prefix. And then we can have all these numbers after it. So you can see here 0b as being 0. This is just 0 because there's nothing there. 0b1, and then a string of numbers after this, which are all zeros and ones. The invalid ones, okay, it's got a decimal number here. This is preceded by nothing. There's no 0b here. And there is a 0b here, but it's got a number 2 in it. We know that 2 isn't one of the digits in binary. And then there's no prefix here. Okay, on to symbolic constants. And this is our last slide. There is a section that's set aside for symbolic constants in your template. And a symbolic constant, rather, is a label that represents a literal. So anywhere the label is encountered in code, it will be interpreted as the value of that literal it represents. So it's a more efficient way of creating constants in embedded programming in that no memory is used in the microcontroller. So this operation is handled by what's called the preprocessor. So if you look at these examples, with the first one, you'll see it's using the define directive with the hashtag define. Pi, you'll notice that it's all caps because when we're dealing with constants, we always communicate them with all caps in that way. Constants are just communicated that way in most programming languages. You'll also notice that there's no semicolon at the end of any of these. Okay. All right, that concludes our introduction to some fundamental programming concepts in embedded C.